Hi, this is Pre-Algebra Lesson 2-2 on page 64 in the Pre-Algebra book, and today we're going to be talking about subtracting integers. In our last lesson that we learned earlier in the week, we learned about adding integers, adding positive and negative numbers. So today we're going to learn about subtracting them, and really that's going to be building on what we already learned. So let's start by reading the introduction. Some roller coasters have maximum drops that are greater than their heights. Riders enter underground tunnels at speeds of up to 85 miles per hour. The underground depths of the rides can be represented by negative integers. So in other words, whatever's below ground on the ride, we can use negative numbers to represent. Subtracting a smaller number from a larger number is the same as finding how far apart the two numbers are on a number line. Subtracting an integer is the same as adding its opposite. So let's look at that. Let's go down to the box below and start understanding what this is talking about. When we are subtracting integers, it looks like this, 2 minus 3. But of course here we're subtracting a number that is bigger than the original number, which means we're going to have to use negatives. But let's go back to the words and think through this. When you're subtracting integers, you change the subtraction sign to an addition sign, and then, so let's talk about that before we go on. That means we're going to make the subtraction sign actually an addition sign, even though we're just adding a negative. Now, as you get more comfortable with negatives and positives, you will probably find that you don't have to do this step, but for right now, where we're really cementing working with negatives and positives, I would like for you to practice this in your homework. So the first thing we're going to do is change the subtraction sign to an addition sign. But if we do that, we've created the opposite type of problem, or the opposite type of math, and so we also need to do the opposite of the sign that the number has. So that means if we change the sign in the problem from subtraction to addition, we've also got to change the sign of the second number. So let's look at what that means. 2 minus 3 is the same as 2 plus negative 3. See, they changed the sign of the problem. They changed subtraction to addition, but because they did that, they also had to change the sign that was on this number. So since we were saying, this is sort of like saying 2 minus positive 3, so we've got to say 2 plus negative 3. So in other words, if we change one, we have to change the other. Let's look at the one below it. 4 minus negative 5. Well, this is a subtraction problem as well, so we're going to make an addition sign. And since we have a negative 5, we've got to change that to a positive 5. So 4 minus negative 5 equals 4 plus 5. Let's look at why that works that way. Not just because of what they're asking us to do, but there's a mathematical explanation behind that. I've told you that whenever anything is butted up against a parentheses, it means to multiply. Well, what if we have a negative sign butted up against a parentheses? It means that that negative has to be multiplied by or distributed to whatever is in the parentheses. So this negative times this negative makes a positive. That's something that we're going to learn in one of our next lessons. Two negatives make a positive. Now let's go a little bit deeper into the math and look at why that is. If we have a negative 5, like you see my pencil pointing to, that really means the opposite of 5, or the opposite of positive 5. That's what negative always means, is the opposite of the positive number. So this means the opposite of 5. But what if we have two negative signs? This means the opposite of 5. So the opposite of 5 is still just 5, because the first opposite of, closest to the 5, made it negative 5. The next opposite of took it back to positive 5. So that's 3 different ways that you can look at this problem: as the opposite of the opposite, or as two negatives multiplied together make a positive, or as the way the book explained it, that we're going to turn this subtraction problem into an addition problem, but then we also have to do the opposite of the sign on the number, the second number. So that means in this case, plus positive 5. And that's what you can see right here. Let's look at a couple more examples. These are with variables, but it's just cementing what we just talked about. a minus b. If we want to make that an adding of integers instead of a subtracting of integers, then we're going to change that sign. And then when we change that sign, we also must change the sign on the b. So this says a minus positive b. But we're going to make it a plus, and then we've got to make this negative b. And this is how we write it. Yesterday I told you if you had two signs next to each other, one of them had to be in parentheses with the number or variable that it goes with. Let's look at the next one. A minus negative b. We're going to turn this into an addition problem, which means we then also have to change the sign on the number or variable. So we're going to make it a plus positive b, which is what you see here. A plus a b without a sign means a plus positive b. All right, let's start applying this in some examples. Subtracting integers. Negative 5 minus negative 5. As you can see, we're going to follow the same approach. We're going to change that sign in the middle of the problem, but then we also have to change the sign on the second number. So instead of negative 5 minus 5, it's going to say negative 5 plus negative 5. These mean the exact same thing. And when we add a negative 5 and a negative 5, we go in the negative direction on the number line twice, and we get negative 10. Or we can also apply our rules that we learned about adding integers. When they have the same sign, we simply do add them, and then we give the answer the same sign that the two parts of the problem had. All right, let's look at the next one, letter B. 2 minus negative 4. We're going to treat this the same way as the book is telling us, so we're going to turn this into an addition problem, but then we must change the sign on the second number. So instead of 2 minus negative 4, it's going to be 2 plus positive 4. And that's what you see right here, 2 plus positive 4. And 2 plus 4 is 6. And remember, we could have looked at this a couple of other ways. Negative times a negative was a positive, so we had 2 plus 4. Or we could have said the opposite of the opposite of 4 is negative 4, which is why that looks that way. And the opposite of negative 4 is positive 4, which is why we can also write it as 2 plus 4. All right, let's look at the last one in this section. Negative 11 minus negative 8. This one is similar to the one above. We're going to make it an addition problem, and we're going to do the opposite of the sign that's on the second number. So it's going to say negative 11 plus 8. But this time we've got to go back to our rules that we learned in the previous lesson. And that is when we're adding two numbers with different signs, we actually find their difference, or we subtract the smaller one from the larger one, and we give the answer the sign of the bigger number. So in this case, we're going to say 11 minus 8 is 3, and then the number with the most value is the 11, and it's negative, so our answer gets the negative sign. All right, let's go to the top of the next page, the top of page 65, and look at example 2, evaluating expressions with integers. This is just building on what we've been doing for several lessons, where we are given the value of a variable to plug in to a problem. So this problem says 4 minus t, and they want us to evaluate this expression using the given value of t, which is negative 3. So we're going to rewrite the problem 4 minus t as 4 minus negative 3, which is what we were told t equals. So 4 minus negative 3 instead of 4 minus t. All right, using the approach that the book is teaching us, we're going to turn this subtracting integers into an adding integers problem. So we're going to change that sign, and it's going to become a plus. But when we do that, we also must change the sign on the number, the second number, and it's going to become positive. So instead of 4 minus negative 3, it's 4 plus 3, which is 7. And reminding you of the other two ways that we can look at this negative times a negative is a positive. So that's one way to get it, to change it to 4 plus 3. The other thing is the opposite of 3 is still 3. So in other words, here we have 3. Just picture that 3 without the negative sign in front of it, and it's a positive 3. But if we put a negative, it's the opposite of positive 3, which is negative 3. And then if we take the opposite of that, we're back to positive 3. All right, let's look at B. Negative 5 minus s. We're going to substitute negative 7 for s. So we rewrite the problem with negative 7 in it. We're going to change the subtraction sign to a plus sign. We're going to change the negative sign to the negative sign on the 7 to a positive 7. And now we have negative 5 plus 7. We are doing an addition problem with two numbers with different signs. So, like we did in our last lesson, we're going to find the difference, and then the number with the greater value, the sign of that number is given to our answer. So here, our difference between 5 and 7, or 7 and 5, is 2, because 7 minus 5 is 2. And our bigger valued number is the 7. It's positive, so our answer is 7. And if you're having trouble remembering why that is, go back one lesson and do that problem on a number line, and that'll help you remember why you land at a positive 2. All right, let's see. Letter C. Negative 1 minus x for x equals 8. We're going to rewrite this problem, substituting the 8 for the x. So we have negative 1 minus 8. Here, we're going to change this to a positive, or change it to an addition sign. So we have negative 1 plus. Now, our 8 was a positive 8, but now we've got to change the sign on it because we changed the subtraction to addition. So this 8 is going to become a negative 8, which needs to go in parentheses, and we have negative 1 plus negative 8. Remember that when we add two numbers with the same sign, we simply move in the same direction on the number line, and the sign that was given to both of those numbers is the sign of the answer. All right, our last problem is a word problem, and this is referring back to the beginning of the lesson where we talked about going underground on a roller coaster and how we treat that as negative space or negative measurement. The roller coaster Desperado has a maximum height of 209 feet. That means the highest it ever goes is 209 feet above the ground. And it has a maximum drop of 225 feet. Well, you can tell that 225 is not going to fit into that 209, so that means that maximum drop takes you underground for part of the ride. So we're going to enter some negative space. How far underground does the roller coaster go? Well, this is a pretty simple setup. We're simply going to say the 209 minus the 225 drop, and it's going to look like this, 209 minus 225. We're going to rewrite this problem as an addition problem, which means we also have to change the sign on our second number. So instead of 209 minus 225, it's 209 plus negative 225. Now we're adding two integers with different signs. This one's positive, this one's negative. We need to find the difference. So we're going to say 225 minus 209, that is 16. And then whichever number was larger, we look at its sign. That's this one, it's negative, so our answer is negative. And that's it. I hope that's a helpful lesson. Rewatch it if you need to. Pause and study things if you need to, or